Everybody have a good Easter, good weekend, for the most part, as best we could.
Yeah.
Yeah, right.
How about you?
Oh, it's always fantastic. I moved 2.5 yards of mulch. I still have 2.5 yards to go. So, welcome to the last week. All right, guys, we're almost done here. Let's finish it strong, and hopefully we'll have some answers as far as what we're going to be using, what we're going to be doing, and everything like that for cruise. All right, I still don't know.
What do you think is going to happen?
I have no idea. I just know I'm glad I'm not the man making the decision, because any which way is going to be, it's just not a good decision any which way. If it doesn't happen, it's not good. If it does happen and everyone gets sick, that's not good. In any way you push it, it's just not good. Everything happening in the world.
Was it up to the Coast Guard to make that decision, or
So
the school?
there's about three entities that are making this decision. You have the captain, because he's in charge. He's in charge of the well-being and the safety of the crew and everyone on board of it. That is his ultimate responsibility, and that's why, you see where in like maritime law cases, where if anybody gets hurt or if there's a problem, even in the engine room, the captain usually goes down with the ship kind of mentality. He still goes to jail. He gets in trouble because it's his responsibility to know everything that's going on aboard his vessel. So you have that. And then you have also, so you have the captain's ultimate decision, and then you have the actual owners of the ship, that's MARAD. All right. So they have to make the decision of allowing us to go out. They are the ones who approve the port list. They are the ones who approve everything that has to go with the ship, the maintenance, when it goes to the shipyard, everything like that, even if it goes out. So, natural disaster can happen and the ship can be activated for, what have you. So they have that entity. And then you have finally the school. And then, of course, the greater SUNY, sort of. So the SUNY and our school at the same kind of level. I'm sure you guys are all aware that SUNY canceled all, summer abroad programs for the summer. But we don't know what we're going to do. So there's like three levels of, and then of course you have the president of the school. So he's in that SUNY blanket. But we'll see what happens. All right. So any other questions before I kind of start pushing us through where we're going to go with today?
So next week's test is just like the three what we just learned. It's not going to be cumulative.
So test 3 is going to be 50 multiple choice. It's going to be on Blackboard. All right. It's going to be in the same format that our other tests and stuff have been in. Now, it's only going to cover not refrigeration. I wish. It's going to cover electricity, hydraulics, and steam. All right. So make sure you study up on those three things. I would, if I were you, download all of our PowerPoints that we have, all right, already. So that way you have them on your computer and you're good to go with no problems on your end. All right. What else? I think that's going to be it. On that, that's pretty much it we have today. And then, so today we're going to be finishing up with the lesson. We don't have that much left. We have slides 23 to 25. So not a whole lot there. Expect the quiz Wednesday. And then Wednesday, we're going to be doing review for test 3. All right. And then a little bit of information of like cruise and whatnot, and what to expect, and any questions you guys may have on that. Because unfortunately, with the school year ending early, where your IDOs and stuff are supposed to take in and talk about this information, they probably didn't have the time to. All right, so just to review, you have your main condenser, all right, your steam. Oh, come on, where's my pen? There it is. So your low pressure turbine is right here, so your steam is coming through. All right, to keep your head straight on what's happening, you have salt water going from your main circulating pump. You can also utilize something called a scoop, which we do have. All right, and then the salt water goes directly overboard. All right, it's all gathered into this little tank that's on the bottom of the main condenser. There's an actual level that we try to maintain with the speed of our main condensate pump. All right, this main condensate pump, where are they located? Because we do have two of them. Where are they located in the engine room?
Port side, lower engine room, I think.
It's not on the port side lower engine room. It is in the lower engine room, but where?
Behind the main condenser.
Behind the what?
Main condenser.
What do you mean behind? I'm not trying to be an ass. I just really, that doesn't make any sense on board a vessel.
The opposite side of the shaft.
The opposite. Okay, there we go. So it's forward. So you have the shaft that comes out here. All right. We have the thrust bearing, which we'll go over in a second. All right. And then you have the main condenser right here. All right. This way goes to AMS. We're in the lower engine room, so there's a door right here, right? And then it is quite literally two pumps that sit right here and here. All right, there's a little walkway that goes right here above it. And then, let's see, we have the OWS over here. Pulling this all from memory. And then we have two auxiliary condensers in the air over here, right? And then we have our feed pumps here, right? One feed pump there, then we have another feed pump, and then we have the import feed pump right there. So let us we are now a liquid, all right, and we are traveling from the main condenser and we're going into the main condensate pump. We have our air drag line. This goes to the main air ejector, all right. So does anybody know what was here? Because the main air ejector is not original to the vessel. What did we use before this? Because I'll give you a hint, there was two of them. And there's still, at least one of them is still on board the vessel somewhere. Does anybody have a guess what we would have used instead of a main air ejector? Like we said, we utilize these things everywhere because they're just fantastic. They have no moving parts. They don't really break. All we use, say again?
Something like that.
Some sort of vacuum pump or something.
We did use a vacuum pump. All right. So we had two vacuum pumps on board the vessel when this vessel was first built. Why would we remove them? Why would we change to a main air ejector if it was originally built with vacuum pumps? Another thing is that we didn't change it at Maritime. This was changed by the original owner of the vessel.
Vacuum pumps are complicated and have moving parts, and Air ejector with a venturi nozzle is stupid simple and can't break that easily.
That, and also there is one other reason. Vacuum pumps, all those reasons are correct.
So loud.
They're stupidly loud. They're actually one of the loudest things in the engine room,
Yeah, vacuum pumps are ridiculously loud.
especially the ones that are going to be bringing down to 28 inches of mercury. All right. That is honestly, they didn't care about the fact that they broke and everything like that. They were fine with it. It would be more expensive over the long period of time to change out to a main air ejector, but they were super loud. And anytime in wartime, stuff like that, and this became a troop transport, and it just amplifies it as a target. All right. So they were removed because you could hear them from quite literally everywhere. All right. There is one on board the vessel. It's located in 6-hold. I don't know what it's hooked up to anymore. But it is the original vacuum pump to the ship. It's still in 6-hold somewhere. I'm going to have to go find it when we go out on a summer sea term at some point. So this is coming from the main condensate pump. All right. So this is coming from our condenser. This is our main steam line. It's no longer steam. It's condensate. It's a liquid. All right. But it is a hot liquid. So what we're trying to do is we're going to try to heat it up a little bit more. All right. We're not trying to cool down our auxiliary steam. What we're trying to do is heat up our main condensate. We're trying to just get as much energy as we can out of it. All right. So we have our air ejectors. All right. It's utilizing the Venturi effect to drag in any of the non-condensables. All right. We're utilizing auxiliary steam as its prime mover. All right. There's 2 sections of the main air ejector. We have the inner condenser and we have the after condenser. All right, they're separated via a wall. So the first portion of it, or the inner condenser, is coming from the main condenser, dragging any non-condensables from the main condenser. All right, and it's pushing it. So now it's all into the inner condenser. It's about 10 to 15 inches of mercury. All right. And then again, any of the non-condensables. So any of the steam. Say again?
Why you just put this stuff downstairs?
No, you can leave it there.
All right. Give me 1 second, guys. So the inner condenser is going to be, remember, it's mixed with steam. It has non-condensables and it has auxiliary steam, 150-pound auxiliary steam. All right. So we want to return any of that steam. It's going to go through a loop seal to the condenser. All right. But we still want to grab those non-condensables out. So it goes through another air ejector and is pulled out and it goes into an after condenser. All right. That drains to the ADT. And any of the non-condensables are kind of pumped out. They go through the air vent. All right. So on the line with our main condensate, it's now heated up a little bit more. And we go to the first stage heater. All right. This isn't utilized on board the vessel. It's actually bypassed. It still exists. We just don't use it. All right. But it's still important to know about it. So we're coming from the main air ejector. And where is the first stage heater located? Where is this located on board the ship? Give you a hint, it's in the lower engine room.
I think it's port side lower. It's right behind those Auxiliary condensers closer to AMS.
All right, so you have your door right here. Remember, this is your door coming from your stairwell, and this is the AMS right here. All right, it's exactly right. It's right here. All right, so that's where your first stage heater is. What's next to the first stage heater?
ADT.
And that's our ADT tank. All right. So remember what we talked about. Always try and keep yourself just a little bit oriented on board the vessel. All right. Whenever we're talking about things, that is, like I talk about, starboard. And over here is port. All right. So a big thing I want you guys to realize is that, I've utilized the language that we have to use. All right. Use starboard, use port, use aft, use forward. All right. So those words actually mean certain things. Give me 1 second. All right. Those words mean things. And when you go out into the industry, people use those all the time. All right. That's not just something that at Maritime we push just for whatever reason. It's because it's actually used out there. All right. I actually find myself saying it in certain instances of life. So let's go back into the PowerPoint. So it's paused. There we go. New share, come on. So as we go through, we have our first stage heater. All right. Basically, we have 3 heat exchangers in one casing. All right. They are flowing through in this orientation. So it's not just going to flow straight up and out, all right, or cross flow like that. That's not going to happen. All right. It's going to flow. There's a wall that quite literally separates the two. All right. So the fluid is going to be moving through. This is our condensate, and it goes through these sections and goes through 3 different heat exchangers, basically. All right. So this is the actual first stage in this spot right here. All right. And then this is the first stage drain cooler. So it's basically grabbing steam from certain instances. So this is our LP turbine bleed. All right. So any of the extra steam that's coming from out of the low pressure turbine, it's just going to be bleeding off into these areas. And we still want to use that heat from that steam. And that's what this is about. It's just grabbing and utilizing any sort of heat that we can manage. All right. Because it's a lot easier to manage heat than it is to create it. All right. Condensate, after it goes through this entire first stage heater, it's going to the DC heater. Now, where's the DC heater located?
All the way up.
That's basically as high as you can go before you hit the stack, right? All right. So we have the DC heater, otherwise known as a direct contact heater. So the condensate comes from the first stage heater all the way down from the lower part of the engine room, and it goes directly into the DC heater. So the DC heater basically it's a surge tank. All right. But it also is doing one other function. All right. It's a scrubbing action. So the scrubbing action of the steam removes any dissolved oxygen from the condensate. The DC heater also is called a deaerating feed tank. The feed water is at approximately 15 psig and it is about 250 degrees Fahrenheit. All right. And it acts as a surge tank because different steaming conditions, you would want basically water that can surge up and down. If all of a sudden we're in a spot where we need a lot more steam and we need to add a huge amount of water into the boiler, you would want to a tank that is at a high temperature already and a higher pressure. So it goes right into the boiler quicker. We can make more steam quicker, all right, and vice versa. If we need to not produce so much steam at a certain spot, if we're maneuvering, all right, we want to give this the ability to raise up as we use our steam, but we're not going to be producing as much of the steam. So it's located high in the machinery space, provides positive head to the feed pumps, all right? So it comes right out of the bottom and it goes all the way down into the lower engine room to the feed pumps. So these are our main feed pumps, all right? We're just going to go into one of them, even though we have three. We have the import and we have our two feed pumps. All right, so we have our suction valve, goes into the pump. The pump is a turbine, all right? So we have auxiliary steam that's going to be supplied to it. So we have the ability to open up these discharge to the main feed, discharge to auxiliary feed. All right, so we have both the port boiler and the starboard boiler, and the port boiler and the starboard boiler on both. And then we have our recirc to our DC heater. So as we continue through, and we're almost done to do the entire steam cycle, all right, we have our main feed and our auxiliary feed. Tell they come from the same line, all right? They're basically the same line, but they're just called two different names. They come in together. We have two stop check valves, all right? We don't have backflow. And then on our main feed is the only one that will have a feed water regulating valve, all right? The auxiliary feed does not. So we go through the economizer. We have two, all right, one in each boiler, and then it goes right into the steam drum. And we're back into our full cycle. So where's the economizer located?
In the stack itself.
In the stack, it's mainly it's physically a part of the boiler. All right, so it's not technically in line here, but up a part of the boiler. So this highlighted section right here is the economizer. All right. And then as we go into the steam drum, which we just opened up right here, this blue pipe right here that we just highlighted in blue, that is where all of the feed water is going to be entering into the steam drum. All right. Again, it's just to make sure all of the heat that we're putting into the boiler, anything that we can grab, any heat that we can grab before we put it into the steam drum will give us an advantage. All right. So that's the main steam water cycle. Before we go into how we use that energy in the turbines, anybody have any questions or anything like that? No? Okay. So let's go into how we actually use that power, all right? Because right now we just have two turbines that are just spinning and they're not really doing anything for us. So right now we have basically a double reduction gear, all right? So when you see these HS, all right, LS, Basically, all it means is just a high speed or a low speed. Okay? Now, these are called pinions right here, and you could see the outline of this one right here. All right? That's basically what that gear is. The definition is just it's a smaller subset of a gear. All right? If you were to put two pinions next to each other like this, they would spin at the same speed. All right? But this will spin in an opposite direction than what this would spin. All right? So we utilize pinions to reduce the speed, but we're going to take is an increase in torque. All right? Because if you had a propeller that was just spinning in the water at high speeds and very little torque, it would quite literally do nothing. You would maybe move a little bit. But what it comes down to is, especially with larger vessels, is a lower speed propeller. You want low speed but a high torque. All right? And that's what we're trying to do with these reduction gears. So we're going to take this high speed pinion, all right, and we're going to create a low speed but a high torque output. All right. So there is the main shaft. All right. We have something called a thrust bearing. Then we have line shaft bearings. And then we have the stern tube bearing. So what is the point of these three bearings? And right here, we have a whole lot more than just one of them on board our vessel. What's the point? Just which one do you want to start with? Do you want to start with the stern tube thrust bearing, line shaft bearings? Which one do we know about? Which one do we want to take a guess at?
Thrust
To what
bearing
it
stops
does.
the shaft
Knows that
from
one of them has duct
connecting back through the ship.
Which one? And what? Two of you going at the same time.
all I know is that one of them has duct tape on them. So I thought that was pretty funny.
Finley, what the
So what's the thrust bearing? I heard that one. What's
Thrust
the-
bearing prevents the torque of the propeller pushing the shaft back up through the ship.
Yes. All right. So if you look at where's the thrust bearing located? We know it's located as the first bearing. But who has an image in their head as to far as where it is in the vessel?
Beginning of shaft alley.
It's the beginning of shaft alley. All right. The next time you guys are on the ship, and I hope it is this summer, and I hope everything is great and it goes away. All right. Take a look at it. All right. You have the main reduction gear that's quite literally right up against it. And you have your main shaft coming out of it. And the amount of bolts that are holding this thrust bearing to the ship, all right, is quite insane. They're quite large. The bolts themselves are about that big. All right. And there's so many bolts and nuts that are holding it to the vessel. All right. They have to take all of the force that's being made and it's actually producing and pushing the vessel. This is the spot that it's actually pushing the vessel on. All right. Now,
How do you fasten those bolts though? They're that big. Like,
so what you'll use is basically is a torque multiplier. All right. And a torque multiplier works on the same principles of reduction gears. All right. So what you would have is that if you have a nut, we're going to say it's a square nut, that needs to be tightened down. All right. What you'll utilize is another either another nut that's been tightened down or something structural on the vessel, and you'll put on your socket on top of it. All right, so if you're looking sideways at it, you have your socket that's on top of the nut. All right, and it comes up like anything else. And you'll have this piece that is a torque multiplier. And a torque multiplier will have basically a structural piece of metal that comes off of the side of it. And that will either go up like against like a wall, or there's special collars that are made that will go over another nut, and this piece will not move. All right. This collar makes it so that way this torque multiplier inside of this portion that I'm collaring in right now will not move. It will be physically kept in that spot. All right. And what you'll use is basically like a giant ratchet that'll come out of it, and you'll have your person that will just be pushing on it, or you could be utilizing an impact gun on it, anything like that. And inside of the torque multiplier will just be a pinion and then a high, like a reduction gear. And depending on what type of torque multiplier it would be how many sets of reduction you would have. All right. That's the older way of doing things. Now what they have is they utilize bolts and they stretch the bolt, and then they'll stretch the bolt inside of it just a little bit. They'll tighten down the nut on it, and then they'll slowly let the bolts go. And then that will put all of the force onto it. That's utilized in diesel engines now. All right. But basically torque multipliers are still used widely. They take a while to do, because what you're going to be doing is you're going to be putting you'll do like 5 rotations on your ratchet, and that will be maybe an inch of movement. But it gives you a huge amount of torque. All right. So then line shaft bearings, basically it's holding up the shaft. All right. Now, what about the stern tube bearing? What about that?
It's like lubricated with salt water, because if oil were to leak out of the bearing and into the water, everybody gets in trouble.
Yeah, exactly. Stern tube bearing is basically kept, all right? It keeps the salt water out, all right? And it keeps everything that we have that's dirty in the bilges and everything like that from getting out as well, all right? It lubricates it with salt water, or it could be a special type of oil. I've seen that before too. But it's basically, all its job is to keep salt water out of the vessel. So double reduction gears are utilized on the TSES, and we use them twice. All right. So again, with those numbers those letters we were seeing, we have a high pressure. So that's talking about our high pressure turbine. All right. It's a high speed. All right. So that means because it's directly attached to a high pressure turbine, it's going to be really moving fast. All right. But not a lot of torque. And its pinion. Okay. It goes to its first reduction gear. That reduction gear is going to be directly attached to another pinion. That pinion is still going to be the high pressure pinion, but now it's a low speed pinion. It's moving a lot slower because you're taking an input that is a high speed, small diameter. All right. And that smaller diameter has to spin, let's say 10 times to get one rotation out of the main reduction gear. And that main reduction gear is directly attached to another pinion that will have to spin 10 times in order for it to move what is known as the bull gear. All right. And it may need to spin 50 times in order to move the bull gear 1 time. All right. These aren't correct numbers. 10 to 1 or 50 to 1 isn't correct. But that will give you an idea of how much these pinions need to move in order to get 1 rotation out of their reduction gear. So, and then we have our low pressure, but it's a high speed pinion. All right, then it goes into its reduction gear. And again, it has a low pressure, low speed pinion, and it's going into the bull gear. All right. So any questions on this? On what's happening with these double reduction gears? One thing I want to show you that I found online.
So is the high pressure reduction gear bigger than the low pressure one because it spins faster?
So it's going to be, basically what you're trying to do is gain the same speed and the same torque out of both. All right. It's not going to be like, what you're trying to do is get the exact same. So the speed and the gearing ratio is going to be different, but it all comes down to what's going to be happening in the second reduction gear pinions. All right. I don't think one is bigger than the other. I know its gearing ratio is different. So let me go into screen share, and there it is. So I'm going to put this up on Blackboard as well. This isn't perfect because it's coming from Massachusetts Maritime Academy, but it is it's our sister ship. So certain things may not be perfect, but it is a good manual. All right. Now this one, if you could see, is what we have here is what our setup is. We have our high pressure pinion, all right, and our low pressure pinion going into our first reduction gear. Then it goes into our second reduction pinions, and then it goes into our main gear or our bull gear. All right. So you could see the difference in size of the actual reduction gears, which are, there's your actual answer. All right. But it is very good information in there. I know there is it's the blue book. Have you guys, do they still sell that book in the ship store? Because there's the green book and then you have the blue book for the engine side. Were you guys told to buy that by anybody?
Which blue book are you talking about?
There is
Practical Marine Engineers, the TSCS Empire State.
TSCS. Do they still sell that?
What I have is white. It's like it's the pony book.
Okay, so you have
Not the pony book.
not talking about the pony book.
I think they had a few copies,
one?
but
Nope.
no, that's the Practical Marine Engineers guide. They had a few copies, but when I went to go look, they didn't have any left.
Okay. Because they had the green book, which was the electrical for the TSCS, and then they had the blue book, which is usually told to you guys to purchase that. But you guys also don't have certain classes that I used to have. Okay, what the hell just happened? There we go. All right. There we go. So not every vessel has double reduction gears, or what we would have is the high pressure, low pressure turbine set up like this. Right. Now these are like electric drives. Alrighty, then we have basically, this would be like a jet engine right there. All right, so it's a gas turbine. This is representing the stack. Goes to a pinion and goes right to a reduction gear, and that goes into a generator. All right. And these represent other generators. They go with their electrical lines right into the motor. And the motor will basically go at whatever speed is needed, whatever RPM is needed at that time. All right. We could also use them with diesel generators. Doesn't have to be a gas turbine. All right. The non-reversing steam basically just keeps, basically the non-reversing steam it's constantly going, it's hooked up into a generator, and that generator is producing electricity to go to a motor. All right, so you're not directly utilizing your steam energy for your propulsion, you're doing electricity to do your propulsion. All right.
So the generator moves at a constant speed then, or the turbine or the diesel engine.
Yeah. So all of those are going to be running at a constant speed. All right. And they're not going to be going up and down. They might just little fluctuations with load, but they will all either run at like 1800 RPM or they'll run at 1200 depending on their rating, but they'll be constant at that, producing electricity at a constant rate. All right. And then it's up to the controller and whatever signal is being pushed out from the bridge to go and say, hey, I want, 18 RPMs right now or 12 RPMs or whatever they're trying to do up there. All right. So we know that on our vessel, on the TSES, there is no direct control from the bridge. All right. They have a throttle up there, but it's not doing anything. It's not connected to anything down in the engine room that will directly control how fast or how slow the ship goes. All right. It's called an engine order telegraph, or an EOT. All right. And these EOTs look like this. Alrighty then. And what they're doing is they're asking for a certain RPM. All right. So their telegraph up on the bridge, ours does not look like this, but we basically are receiving orders from the bridge. They go and they'll basically say, hey, we want slow ahead, and they'll move this bar across. All right. And there'll be a smaller arrow. You can see it right here. I'm going to change my color. Nope, that's not good. I'm going to go for purple. All right. So there's an arrow in here. All right. And that's what we're going to be controlling down in the engine room. All right. So if they move the EOT, they will show that they have, hey, we want slow ahead. All right. And we have to match it. This will ring, and it'll basically ring to let you know that the bridge wants a different speed. You will basically take the engine order telegraph and you'll change the arrow location and you'll match to the arrow and basically say, hey, we acknowledge that you want slow ahead. All right. That's all this is. It's an acknowledgement of what they are asking for. Let me clear all that so that's nonsense is not there. All right. You can see that they're asking what they want is on their brass knob up there. what we are saying that we have, or what our acknowledgement level is their blue arrow, and vice versa. All right. So remember, this is not an direct influence. You can't just sit up there on the bridge and go full head to full stern and just back and forth and doing whatever you want. It's not going to control the boilers. It's not going to control how much steam goes through. All right. That is all done by the engineers. All right. And the big thing that you have to do when you're operating the engine order telegraph, because it is a position for a freshman to be doing. All right. A couple of things have to happen. One, you have to write it down in the bell book. All right. Two, the other thing you have to do is you have to acknowledge what the bridge is asking for. All right. You have to match the arrows up so that way you don't have this constant ringing going on. And then three, what you have to do is you quite literally have to yell it across the engine room from the engine order telegraph. You have to yell across two turbines to the boiler area. Why do you have to yell what the bridge wants across? One, it's loud, that's why you have to yell. But two, why are you yelling to the people at the boiler?
They're the ones controlling the speed.
They're the ones who are controlling the steam. All right. What the boiler is going to be doing, those guys at the boiler controls. All right. Those are our boilers. All right. They have their control system right there. All right. Then we have our two turbines. Whoa. We have our two turbines. And then we have our throttle control position there. And right next to the control throttle is our bell book and our EOT. All right. Bad placement because the door is right there, unfortunately. So you really do have to yell across these things. But our throttle box is right here. That's what's actually physically controlling how much steam is going into our turbines. All right. But the guys who are doing the boilers are also controlling the water level. And what else are they controlling?
Air and fuel flow.
The air and fuel flow. Okay, so how many burners are online? All right. They also have other responsibilities. They have the water level. They have the number of burners. They have how much steam is being produced. All right. Because remember, if we're asking for more steam in those turbines, we have to get it from somewhere. All right. And that somewhere is these boilers. They're not going to be constantly just producing a certain volume of steam. All right. How many burners online depends on how much steam we're going to produce, how much heat we're producing. All right. That's why we have two boilers that have 4 burners each. All right. That's why if all of a sudden someone over here is going to open up the steam valve all the way, we'll run out of steam really quickly. They need to account for that by, if we want to use all the steam and go full blast, we would need to have all our 4 burners on. We would need to start opening up our throttle slowly to let steam out. All right, and as we're letting steam out, we're going to have to increase our water level in the steam drum, because now we're going to be, 1, producing more steam, but 2, we may lower our pressure in here because the volume of steam that's coming out is going to be high. All right, so we have to maintain our water level to constantly be producing a huge volume of steam. especially added that we have 4 burners online, it's going to be a lot hotter and producing a huge amount more. That's the importance of yelling across the engine room. And don't be afraid to yell. And if people are having conversations, it doesn't matter. You just yell it across the engine room. All right. So we have the bell book. And basically, you have these different symbols that you would have to write down, because you can't just take and write these words down really quickly in a small bell book. All right. When you're maneuvering, you have just a few seconds to write these things down. Oh, geez, guys, why didn't you tell me that it's 11:15, past 11:15?
Okay.
Someone in the chat told me.
Learning.
Oh, my God.
We were that focused.
Yeah, so was I.
I felt kind of
All
bad.
right. So we're going to
break
go
the
up to slide.
concentration.
So let's stick to it. Let's do 33. All right. We'll finish up the rest of this on Wednesday. All right. You can tell I enjoy talking about Steam. I will see you guys all on Wednesday. All right.
What's the quiz on? What
All right,
slide?
thank you.
Slides are going to be from what we left off to slide 33.
Okay.
Sounds good. Thank you.
All right.
Good day.
Also, Alex, I like your background.
Thank you.
No problem.
God. Fuck. Can you hear me?
Yes,
I have a final conflict.
you do.
Yes. So I have the exact same time I'm supposed to have yours. I also have that was it. Intro Thursday. I have dynamics. So is it possible that should I email you but move it either before or after our scheduled finals time for our exam?
Yeah, so we'll work it out then. I forget the ordering. I know it's always supposed to be major first, then everything else, but it's both one and the same at this point. My final is only going to be an hour. So, but it all comes down to we'll reschedule. It's not like I'm not going to expect you to study for 2 finals at the exact same time and take them right after each other.
Well, no, it's that they're the exact same time. Both are at 08:30 to 1200 Thursday.
That's what I'm saying. I'm not going to expect you to come in at like 12 for my final and vice versa, like an hour after.
I'm not worried about this final. It's the only one that I'm not worried about. So whatever you want to do.
I'll make yours harder.
Give me extra points. I'll do it.
All right.
This is going to be my grade booster for dynamics. It's my counter.
Oh, God. All righty then. We'll work it out. Email me. All right. And we'll figure out a time that works for us both. Same as always.
Have a good day.
All right. Thanks for letting me know.
Of course. Thank you.
Yep. Have a good one. Anybody else need me before I let this go, or?